Welcome to EDU World Space.
So here for part A, the pressure of the input will be equal to the pressure of the output, and we can say force in over cross-sectional area of in equals force out divided by A out. We can then solve for A in, so the cross-sectional area of the input will be a cross-sectional area of the output times the force sub in divided by the force sub out. And we can solve. So this will be equal to pi times 0.09 meters squared times 920 kilograms times 9.8 meters per second squared. And then the force of the input would be only 350 newtons. And so the cross-sectional area of the input would be 9.878 times 10 to the fourth meters squared. So that would be your answer for part A. For part B, we want to find the work done by lifting car is going to be equal to mgh, because the force to lift the car, the only force that it's going against would be gravity. So this would be equal to the mass of the car, 920 kilograms, times 9.8 meters per second squared, times the height it was lifted, 0.42 meters. And we find that the work done is going to be approximately 3,787 joules. So that would be your answer for part B. For part C, we know that the work done by the input piston is going to be equal to the work done by lifting car. So the work of the input rather equals the work of the output. We can say that the force of the input times the distance of the input equals force of the output times displacement of the output. And we have that the force of the in times the displacement of the in equals mgh. And so to find the height, this is simply going to be equal to force sub in d sub n divided by mg. And so let's solve. So this is going to be 350 newtons times 0.13 meters divided by 920 kilograms, and then times 9.8 meters per second squared. And so h is going to equal 5.05 times 10 to the negative third meters. So this would be your answer for part C. For part D, we want to find the total number of strokes. So we know that the number of strokes would be equal to the full distance divided by the distance per stroke. So the total distance, or the total displacement, would be equal to the number of strokes times the distance achieved by one single stroke. Therefore, the number of strokes would be equal to the total distance divided by the distance for one stroke. This is going to be equal to 0.42 meters, and then this will be divided by 5.047 times 10 to the negative third meters. And we find that the total number of strokes for part D is going to be equal to approximately 83 strokes. So 83 strokes of the piston in order to lift the car. Now for part E, we're trying to find the work of the input. So the work of the input would then simply be equal to the number of strokes times the force of the input times the distance of the input. And this is equaling 83 strokes times the force, so 350 newtons times 0.13 meters. The work done by the input, which would be equal to the work done by the output, would be equal to 3,777 joules. And again, this is only occurs because here energy is conserved. So this would be your answer for part E. That is the end of the solution. Thank you for watching.